For the first question, we need to find the first derivative dy over dx for two distinct functions. Question A shows us a polynomial binomial to the power of 5 multiplied by ln 4x plus 1. As for question B, we have a rational function with a trigonometric cosine function in the numerator and an exponent function in the denominator. Let's go through the solutions for both questions. For question A, we can see that two separate functions are multiplied together. This means that we need to use the product rule. The formula of the product rule is dy over dx is equals to u multiplied by dv over dx plus v multiplied by du over dx. Firstly, we need to break down our terms. Our u will be 4x plus 10 to the power of 5 and our v is equals to ln 4x plus 1. For u, we need to bring the power of 5 to the front, keep the inside the same, and then we need to minus the power by 1, which will give us 4. And then we need to multiply it with the derivative on the inside, which is 4. So our du over dx will be 4x plus 10 to the power of 4. Moving on to v, the derivative for ln will be 1 over 4x plus 1 multiplied by the derivative of inside, which will be 4. So our dv over dx is 4 over 4x plus 1. Lastly, we need to insert all of the values into the product rule formula. So our dy over dx will be 4x plus 10 to the power of 5 multiplied with 4 over 4x plus 1 plus ln 4x plus 1 multiplied with 4x plus 10 to the power of 4. Moving on to question B, this function is a fraction whereby one expression is divided by another expression. This means we need to use the quotient rule. The quotient rule formula is v multiplied by du over dx minus u multiplied by dv over dx divided by v to the power of 2. And our v will be e to the power of 2x minus 5. For u, the derivative of cos will be negative sign. Keep the inside the same. And then we need to multiply it by the derivative of the inside, which is 3. So our du over dx is negative 3 sine 3x minus 2. As for v, the derivative of an exponential function e is just itself multiplied by the derivative of its power, which is 2. So our dv over dx will be 2e to the power of 2x minus 5. Lastly, we need to substitute the values into the quotient rule. So our dy over dx will be e to the power of 2x minus 5 multiplied with negative 3 sine 3x minus 2 minus cos 3x minus 2 multiplied with 2e 2x minus 5 divided by v to the power of 2, which is e 2x minus 5 to the power of 2.
We are given the equation 10x cubed minus 4x sine of y squared equals 1 over e to the y plus 5 ln of 3x minus 1. And we are tasked with finding dy dx using implicit differentiation. Unlike regular differentiation, where y is isolated on one side, here y is tangled up inside other function. The key concept to remember is this: we differentiate everything with respect to x as normal, but whenever we differentiate a term that contains a y variable, we must attach a dy dx right next to it because of the chain rule. Before we start applying calculus, let's apply a quick algebra modification to the right side of our equation. The term 1 over e to the y can be written as e to the power of negative y using the rule of negative exponent. This gives our term strictly linear and completely bypass an unnecessary quotient rule step. Our modified equation is 10x cubed minus 4x sine of y squared equals 1 over e to the power of negative y plus 5 ln of 3x minus 1. Now let's take the derivative of each of these four terms across the equal sign, moving from left to right. Term 1 is 10x cubed. This is a basic power rule function of x. We bring the 3 down, multiply it by 10 to get 30, and lower the exponent by 1, giving us 30x squared. Term 2 is 4x sine of y squared. This is the core challenge of the entire problem because 4x is multiplied by sine of y squared. We must use the product rule where our u equals to 4x and our v equals to sine of y squared. The derivative of u is straightforward, become u prime equals to 4. To find the derivative of e, which is sine of y squared, we use the chain rule. The derivative of the outer sine function become cos y squared. Then we multiply by the derivative of the inner y squared, which is 2y. And since this is a y term, we must attach dy dx. This gives us v prime equals to 2y cos y squared dy dx. Putting u prime, v and v prime together into the product rule formula, term 2 becomes 8xy cos y squared dy dx as 4 sine y squared. Moving past the equal sign to term 3, we have e to the power of negative y. The derivative of exponential function is just itself e to the power of negative y. We multiply it by the derivative of its exponent, negative y, which is negative 1, and we attach our implicit marker, dy dx. This simplifies cleanly to negative e to the power of negative y dy dx. Finally, term 4 is 5 ln of 3x minus 1. For ln, the rule is to put the derivative of the inside function over the original inside function. The derivative of 3x minus 1 is 3. Multiplying this by the constant coefficient 5 gives us 15 on top over the original bracket, resulting in 15 over 3x minus 1. Let's look at our fully differentiated equation on the slide. Our goal now is to isolate dy dx. To do this, we rearrange our terms. We will gather all the terms containing a dy dx vector onto the left side of the equation and move all independent terms over to the right. We bring negative e to the power of negative y dy dx to the left, making it positive. At the same time, we move 30x squared and negative 4 sin y squared to the right, reversing their sign. This gives us. Now we factor out dy dx as a single common factor on the left side. For our final step, we isolate dy dx completely by dividing both sides by the entire expression inside the bracket. Our final implicit derivative is. This concludes the solution for question 2.
In question 3, we are given two functions whereby one of them is a rational function and the other one is a radical function with root of 4. And we need to find the estimated value by using linear approximation, and our final answer must be correct to 3 decimal places. And the core formula that we will be using in this question is fx null plus delta x is approximately equals to fx null plus with f prime x null multiplied by delta x. In step 1, we will define the function whereby we will create the general function by replacing the decimal value with variable x. Hence, our fx null will be equals to 2 over square root of x plus with x root of 4. And we will write both of the terms in the exponent form, whereby it will be 2x to the power of negative 1 over 2 plus with x to the power of 1 over 4. In step 2, we will be splitting our target value, whereby we have x as our target value, that is 0.44, and we have our x null, which is our base number that is close to 8, and we go with 80, and then del x is the tiny difference that happened between these two numbers, whereby it will be 0.44. How do we know that? We can determine it by using this formula, where we have x equals to x null plus del x, that gave us x equals to 80.44 equals to 80 plus what number that will give us 80.44. Therefore, we know that logically it needs to be added with 0.44. Or we can determine it with this formula, which is easier, whereby we can directly subtract x with x naught to find del x, because we already have the value of x here given 80.44 and we have our value of x naught. Therefore, we can find the del x directly, which will give us the same answer, 0.44. And that's how we get our del x. In step 3, we will find the derivative function, whereby we will differentiate the function to find our f prime x. And we already have our fx in the exponent form, which will make it easier for us to differentiate it. And we will apply the basic power rule to both terms to find our f prime x. So the first terms, we will bring down the power and multiply it with 2 and subtract the power with 1. And this will give us the value of negative x to the power of negative 3 over 2 plus with the second term. We will do the same thing. We will multiply the power with, we will bring the power down where it will be multiplying with 1. Therefore, we have 1 over 4, and we will be subtracting the power with 1. And this will give us the value of 1 over 4x to the power of negative 3 over 4. And this is the value of our f prime x. Now in step 4, we will evaluate the function and the derivative, which is the fx and the f prime x at x null equals to 80. So we will do for the first one, which is the function fx equals to 2 over square root of x plus x root of 4. We will just going to substitute the value of x null into it. And we will find our answer by using the calculator, which will give us 0.2236 plus with 2.9907, and this will give us the value of 3.2143. Moving on to our f prime x, which we already find in our we already find the derivative in our step 3, and now we will be substituting the value of x null into the derivative. And this will give us the value of negative 0.001398 plus with 0.009346, which will give us the final value of 0.007948. Therefore, we already find our f prime x and our fx here. So now we have reached our last step, whereby we will be substituting all of the values into the linear approximation formula. That is the core formula that we will be using for this question. So we will directly substitute each of the values that we have found in the earlier steps into the formula, whereby fx null plus with del x is approximately equals to fx null plus with f prime x null multiplied by del x, and this will give us 80.44 approximately equals to 3.2143 plus with 0.003497, and our final answer needs to be correct to 3 decimal places. Therefore, this will leave us with 3.218. Hence, we already find our final answer for this question.